Hi everyone, my name is Alon. I accepted this challenge. I'm an architect in Midokura, where we develop Midonet. Midonet is an open source network virtualization software. And in my short time, I'll try to explain what we're doing. So the idea is to implement neutral services like load balancer, VPN as service, routing protocols as containers rather than taking the standalone or monolithic approach. Okay, so this approach fits very well third-party software like HA Proxy or Quagga, for example. Instead of writing our own proprietary code and deeply integrate with Midonet, we deploy them as lightweight containers. Why containers? So first of all, they all share the similar life cycle. They need to be scheduled, started, monitor, sometimes migrate and move around in case something happens. In terms of scalability, it's very easy, quick, and very low cost to create more of these instances when demand or the load gets higher. Resiliency and high availability, so both containers and the hosting compute are being constantly monitored for their health status. And if something happens, the controller spawns another network service somewhere else. We can have different implementation for the same network service. For example, HA Proxy or engines for load balancing, or Quagga or Bird for routing. So we can choose based on our prefer. And last, manageability is made very easy for the operator. So he can spawn, monitor, set policies in very easy way. Taking a top-down look, we have on top the Neutron services, right below the Neutron layer, and then we have the Neutron plugin. The Neutron plugin is the binding to the implementation of the network. In our case, Midonet, where we have the port to which the service is connected. We have the service container that actually holds all the information about this container. And we have container group that defines the scheduling policy. To support that, we have a container service running as a cluster minion, which is responsible for the entire lifecycle of the service. And we have some code running on Midonet agent on the compute host side. What happens when a service is configured? So first we do the translation from Neutron to Midonet objects. Then we schedule a container on a compute node. The selected agent then launches this container. And once it is launched, the agent constantly monitors the status and the health of this service. And the controllers monitor the status and the health of the computing host. Let's take a look at this VPN example. We have IPsec containers connected to dedicated router ports on the tenant routers, which create a tunnel between these two networks, Mercury and Venus. Inside Midonet, this is supported by a port, which is allocated for the service container. We put redirect rules that actually match traffic between these two networks, and we bind the container port to the data path on the hosting compute. We'll finish talking scheduling policies, and first is the affinity policy. We have 3 of them. First one is anywhere. Practically no affinity, meaning the service can run on any of the available hosts. Second one is host group, in which we select a host from a predefined group. This is useful when we have hosts which are more capable for doing this job, like have better I/O or stronger CPU. Last one is port group. Here we select a host based on the port ownership. For example, for BGP, we want it to run on gateway nodes, which are defined by owning uplink ports. For selection policies, we have 2. First one is weighted, which is static. Based on matrix that defines the probability of a host to be selected to host a network service. The second one is based on live data, which is list policy, and here we select the host with the least number of running network services to run this service. Now, by now, I'm sure you're all eager to go home and try Midonet, and I sure hope you'll do. Thank you very much.
All right, thank you, Alon.